Hi there, I'm Noah, and this is my video covering the second public lecture assignment. For this assignment, I chose to attend, or watch, Professor Junker's public lecture covering the presence of physics in everyday life. I found this lecture particularly interesting because it covers the many moments that happen during breakfast where physics is taking place, and it helps contextualize just how important science is to our everyday life. And so Professor Junker also helps further some of these ideas and explains how they've been used in other places and fields. And then finally, he goes over why being able to test assumptions is important, such as how you can prove scrambled eggs to be proven more solid than liquid beyond simply looking at them. So one of the interesting things that I learned is that the coffee ring effect is a real thing. You know, if a liquid or a solution is spilled and there's a darker ring around the outside and then the inside's a lighter color. And so this effect helps explain why this happens, drawing into a gradient. And so this happens by the different attracting and repelling forces between the water molecules and the solution molecules. So whatever you added in the case of the coffee ring effect, it's originally done with coffee. And when combined with surface tension and evaporation, the coffee molecules in this case will end up separating from the water and will form the stronger exterior ring, while the water on the inside ends up evaporating. And so while this may seem like it's an interesting but pointless effect to observe and to explain, it turns out that there's been other places where this effect has become very applicable and useful, such as with using it in ink printers and even when testing for various diseases such as malaria. So this lecture helped me think more about how physics ends up being present in our everyday life, as was its intent. And one of the most immediate objects that came to my mind was the fridge. And fridges act by reducing the kinetic energy in food, slowing down their molecules, working to preserve them. And this also ends up slowing down the growth of bacteria and other undesirables that may end up on your food intentionally or unintentionally by doing the same thing, by slowing them down. And so it's interesting to me how we generally end up taking these appliances, such as refrigerators, stoves, microwaves, and so on, for granted in our everyday life, but we never really think about how they work or their application of physics or the amount of work that was put into actually constructing them. And then I also did some further research into the coffee ring effect. You can see the link that I found below it, but as it turns out that if you add a little bit of salt to a solution, when compared to the solution just on its own, the solution with the salt will end up not experiencing as strong of a coffee ring effect, or it won't experience it at all. So the stain will end up leaving a smoother gradient, or it will end up drying all as the same color. And I found that very interesting, and that makes me want to look into why it was salt in particular that caused this reaction and not some other molecule or compound. Anyways, that's all for my public lecture 2. Thanks for watching.